Excellent. Okay, great. So welcome to DUNE Computing Training, May 2021, day number 2. Ken, the floor is yours.
All right, tell you what, I think I am gonna turn my video off to save bandwidth. Then I'm gonna share the screen. Maybe.
Yes, we can see very well.
Okay. All right, so as proof that this all works, I have done this stuff already, yes, but I will also do it with you at the same time. So we will go over several things this morning, right? We will actually submit jobs, understand what goes in a good script. We will monitor the jobs if Python starts working again, which it hopefully will. Then we will review best practices, and actually most of the emphasis will be on that, as it turns out. And then at the end, I will demo POMs, and then you can have a homework assignment to try to make your own POMs campaign that submits a small test job. All right. So first thing we should do is log into your favorite machine, DUNE, GPVM, whatever, or this should actually work from LX Plus. The only thing extra you would have to do is get a Kerberos ticket for KX509 to work. And you might have to do an extra, after the setup jobs of client step, you might have to do a setup KX509. I haven't done this on LX Plus in a while, so I will be demoing from Fermilab though. All right, so we're gonna go here, and that is probably really hard to read.
If you can zoom a tiny bit. Yeah, perfect.
Okay, so I already tried this earlier, as you can see, but let's just clear the terminal. Okay, so I'm gonna go to DUNE GPM 15, but be sure to spread out, right? Because remember, the GPVM machines only have 4 cores each, and about 10 or 12 gigs of memory, depending which one it is. So it is very easy to overload them. Okay, so logged in. Let's do the first couple of steps. Since we always need to set up some software. Now you'll notice in this case, to keep it as simple and generic as possible for the initial example, I just did set up jobs of client. Now, if you do something like set up DUNE TPC, you get jobs of client for free. So if you're already used to doing set up DUNE TPC or a number of other packages, that will cover this too. All right, so what we're going to do is just get right into this, because I think the best way to do this kind of stuff is to just do it. So once you're logged in, these files are accessible to you. They're just in my DUNE app area. So basically just cut and paste this entire command. Maybe. There we go. Cut and paste that into your terminal and let it rip. Like so. Okay, so you should get output like this. You get a job ID number. Now, when you're manipulating things later, if you want to, fetch logs or hold or kill the job, you'll want to make note of this number, but you'll need the whole string. You need the at job sub 1, 2, or 3, finale.gov on the end of it too. All right, so your first question is, once you've done that, just make a note of what your job ID is. And as I said, you need the full string. All right, so has everybody done that? Mostly? Put a thumbs up or something if you've done it.
Yes, please send feedback so that we know if things are okay or not, and feel free to ask questions so that we can help you accordingly.
And it just worked for me, so it, you know, the job sub server is up. So
can I keep track on the live docs, and I will tell you if there are some questions on the live doc. But so far, you got there are some thumbs up. So
okay. Oh, can you send me the link to the live doc again?
I will actually.
I have the wrong, as you see, I have the one from yesterday, which is good, but not so useful at the moment.
For people,
there we
chat it on the chat. So for people arriving late, they can see it.
All right.
Yes. Okay.
Okay, good deal. All right, so back to the explanation. So let's look at what we actually did here, right? Right now, can I get this all in one? Yeah, not really, because it's too small. Okay, so you run job submit is the main command to submit. Right now, when you're using POMs, for example, and submitting large workflows, it's actually doing a series of job submits behind the scenes. But this is the basic tool that you would use. Now, later on, we may be offering some direct submission with just a bare Condor submit through other means. Look for that in the coming months for just some additional options, but job submit will keep working in that case, right? Okay, so I go through the options here, and let's make sure we understand what they mean. Is that a little better for reading?
Yes, it's great.
Yeah, okay. All right, so the first one you will see there, okay, so there's a -M, which just sends you an email when the job finishes. That will happen regardless of whether the job succeeds or not. The default, if you don't put anything, it will send you a mail if the job fails. The other option you can use if you're submitting, you know, hundreds or thousands of jobs, you can do the mail never option instead of -M. Then you won't get any emails. Second is the -N option. So this will control the number of jobs that are submitted at one time. So if you want to do, you know, simulation, for example, you want 10 or 100 or however many copies of the job, and then maybe each one does something slightly different, for example, you can do one submission instead of submitting 100 times, for example, right? Much more efficient, as it turns out. So what will happen is then this job, the number, sorry, will, in the job, will be available to you in an environment variable called process. And then that will go from 0 to n-1. And then if you look at the job IDs, when you're looking for a specific job, then you'll have some number, and then there's the dot, and then the n is the process number. Now in our example, we only have one, right? So it's just you just get a 0. Now, if you submit,
and there's a question that says, "What is an identical job?"
Well, it's it would run the same script and then have the same inputs and environment variables to it.
Thank you. I write it down. Okay.
So imagine I had some parameter set I wanted to iterate over. So then I could run however many jobs corresponding to however many different iterations I needed to do. And then my script could, for example, use that process number to decide which iteration it was going to do. Does that make sense? What I was going to do later, I can show you a little bit of some of the production scripts and configs, and you can see a lot of this stuff in action. Yeah, we do that, I think, all the time, right? So, all right. So going on then. So the next options are kind of the key ones. So there's one for memory, there's one for disk, one for number of CPUs you want, and then expected lifetime, which is the maximum amount of time you expect your job to run. As in, it could run up to 8 hours or 24 hours or whatever. Okay, the defaults then are 2000 megabytes, 10 gigabytes of disk, 1 CPU, and 8-hour runtime. So if you don't specify one or more of these options, those are what they will be set to. Now, if your job should exceed any of your resource requests, it's going to go into a held state, which means later you will have to release it, and then it will start over from the beginning. Then there's a concept then of how much, at least when you're running on FemiGrid, this does not apply when you're running outside of Fermilab, as we'll see, of a quota. So each experiment has a certain number of resources they are allowed to use at one time. If you go over your quota and there are available resources, you can go over your quota and that's fine. But then if somebody else comes in and they're under quota, they will have enhanced priority of starting jobs until they get to their quota. Does that make sense? So how are you charged, so to speak? How much does your job consume of the quota? So it's calculated according to memory divided by 2000 megabytes and the number of CPUs, whichever is greater. And there is fractional charging. So as you see here in the example, right, if you ask for 3000 megabytes of RAM, you would be charged 1.5. 4000 would be charged 2. Now, if you asked conversely for, say, 1000 megabytes and 2 CPUs, you would be charged 2. Okay. And always remember, right, you are charged for what you request, not what you actually use. So if you ask for 4000 and figure, oh, that's way more than I'll ever need, I never have to worry about going held, then that is not good, because one, you are limiting yourself as far as how many jobs you can run at one time, right? Because it's going to block as much memory as you requested. And you could be using that memory to run another job, right? Or maybe 2 other jobs, depending on how much you ask for. That will affect not only you, but everybody else on your experiment. So, general rule of thumb, only ask for what you need. Keep in mind also, the more you ask for, the longer it will take to start your job, because it has to find a worker node out there that has enough free CPUs and or memory, right? So it's basically, think of Tetris. Basically, you're trying to fit the pieces in somewhere, right? And the bigger and more complicated piece you have, the harder it is to fit. So it's quite intuitive, actually, right? Now, as I said, right, if you're not running on FemiGrid, that doesn't count. You don't have to worry about quota. If you can get 10,000 cores offsite, more power to you. I encourage you to do that. That depending on what you ask for, probably is possible, actually. As long as you're not asking for, 10 gigs of memory per job. But the thing to keep in mind is, like I was saying earlier, if don't ask for way more than you know you're going to need. The better thing to do, and there's actually empirical research on this, as it turns out, and you actually win in the long run in terms of overall job throughput. Set your memory and your runtime requests to cover kind of 90 to 95% of your jobs on the first pass. Now, of course, then there's going to be that little tail of jobs that take longer or need more memory. And we have this auto release feature, which we can come back to later, I think. And what will happen there is if you go over your initial requests here, it will automatically release the jobs for you with a higher memory or runtime request that you can tell it how much more to add the second time. So then you don't have to sit there and manually release stuff all the time and babysit it. So that is a great help. I'd say everybody wins when you do that, right? Because you don't have to make such big initial requests. Okay, other key one is this resource provides equals usage model, which is not at all intuitive, I admit, as to what it does, but it's basically controlling where your jobs are allowed to run. There are 3 words you can use in any combination. So if you add dedicated, that is run on memory grid, but only use quoted slots. So once DUNE is at its quota, you cannot run anymore until something else finishes. Opportunistic means if there are available resources on memory grid beyond the DUNE quota, use them. And then offsite is everything not at formula. The way to do this is you just combine these terms in a comma separated list. Now, as you will immediately see, there is absolutely no downside whatsoever to including opportunistic all the time, right? Why not use resources if you can get them? So you should always have opportunistic in it. In pretty much all cases now, anyway, you should be running both on-site and off-site and just let the server figure out what the best place is to run your job. That does 2 things. It gets you more resources in the end, because the DUNE quota is finite, right? And it will help your jobs start faster. Now, in the past, depending on how long you've been around or depending on who you talk to, you may have heard people complaining about, well, offsite's slow and sometimes there are, missing libraries on the worker nodes of the other sites and then your job doesn't work, whatever. The way we get around this is when we are running offsite, if a site supports singularity, which is basically just a container, sort of like Docker, but a little more secure. At sites that support singularity, which last time I checked was greater than 99% of all resources, it will by default set up a container which is built from the same Docker file as the memory container. So you get exactly the same environment. So there's no difference anymore between Fermi worker nodes or anywhere else. Now, of course, there may be a little bit of speed variation from worker node to worker node, as there always is, right? But in general, offsite nodes are on average just as fast, or maybe in some cases faster than average memory grid nodes. Of course, there's maybe a little bit difference in network latency depending on where you're getting your data from. But as far as that being an impediment to running offsite, it really shouldn't be. Production does it all the time, and so should you. Okay, then -L, you don't have to use too much, but can very much come in handy depending on what you're doing. This is just stands for lines. What you can do is just pass HD Condor style class head variables if you want to have different things set up. Now, what we did in our example up here, going back here for a second, you'll see we used it like this. And we explicitly told it what singularity image we wanted to use for when we're running a singularity. Now, as it turns out, this happens to be the default one, but you don't have to use the default one if you don't want to. If you have some other image that is accessible on the worker node, you can use it. You can just specify it here. In general, you want to be getting things out of CVMFS, and we talked about CVMFS yesterday, because that way you know it's available on all worker nodes. If you have some other image you think you need to use that we should get into the Singularity OpenScienceGrid.org repo, we can do that. There are mechanisms for that. For example, if you wanted something GPU specific, that kind of thing. But anyway, there are other things, of course, you can pass here as you need to. We'll come back to that in a little bit when we talk about auto release, but it's a very, very handy tool. What I recommend doing pretty much for all jobs is just explicitly specify the singularity image. That way you get exactly the same thing everywhere. And as it turns out, actually, even on FermiGrid, you have been running in Docker containers since September 2017. You just didn't realize it. But if you specify singularity image like this, FermiGrid will pick up on that, and it will also invoke the same singularity container. So you're running singularity inside Docker. But then you really, truly do have exactly the same environment on every single site. Okay, then the last thing is this append Condor requirements. So these are kind of requirements. The difference is, so class heads are basically kind of like environment variables. Requirements are basically, these things must be true before my job starts. So for example, what did we do up here? I said, all right, target, which is the worker node, and my is my job. So I said that the has singularity environment variable must be set to true. Okay, I want to make sure singularity is working. That makes sense, right? I require that it detected and determined that the DUNE OpenScienceGrid.org CVMFS repository was working. Also important, kind of important, right? Same thing with the larsoft repository. And you can also, if you want, so imagine you were running jobs on a brand new DUNE TPC release or something, right? Now, when stuff gets put into CVMFS, there's a little bit of a delay. It can range anywhere from minutes to maybe some, in the extreme cases, a number of hours before that actually shows up in the worker node. So what you can do here to protect yourself is there's a command you can run. I didn't include it here, but if people are interested, I'll put it in the live doc. Remind me to do it, somebody. You can see what the current version is. It just spits back this number, and then you just say, okay, the version of the repo that's on the worker node has to be at least this number, and that way, that means that my new release or whatever I need has already shown up on that worker node, and my job won't blow up because it landed randomly on a node that died or hadn't been updated yet. Sorry. And then the last thing is, this is the actual script that you want to run in the job. Fair enough? All right, let's pause real quick for questions. Anybody?
I don't see anything on the chat or then.
Looks like Yeah, it looks like Kirby is handling that. Thank you, sir. All right. How are we doing on time? Okay. All right, so our job ran and hopefully it completed. My other one did finally. Okay. Cool. So basically what this first job does, we can look if you want at the script, but maybe we skip that in interest of time unless anybody really wants to see it. Basically, it just pokes around and makes sure that you're actually running in Singularity is all that does. So basically, I just use this to test new sites, essentially.
Perhaps, Kane, to have an idea, can people please thumbs up if they follow, they're all good, or thumb down if they have some problems and they want actually to see more of the scripts? But we really need feedback. We do this for you, so that would be nice. Okay, one thumbs up so far. They're just, we have a lot of thumbs up, Ken. And
okay, good, good.
That's sent across like a sort of
all right.
Yeah, but otherwise I think it's good. Thank you so much for sending feedback. That's helpful for us.
Okay. All right, why don't we go on then real quick and let's do the job output bit here. So if we were to look at the script, which I guess we're not, but that's fine. What it ends up doing is it makes a single output file, which will go to PNFS Dune Scratch user, your username, job output, then that job ID number, but without the @ job sub whatever, because Bash doesn't always like the special characters, right? So it's just the first numerical part. So let's go back over here and let's see if it ended up there. Now, this is not a root file, so I can't open it with extra D. Otherwise, I should, right? We talked about this yesterday. But okay, this is a small text file. I'm not trying to open 50 of them or 1,000 of them at once. So, okay, we can probably just read it over manifest, right? Job output 4389. There we go. There it is. So again, don't get in the habit of doing this, just reading directly over NFS, especially with root files. But okay, so basically what did it do? It printed out a bunch of stuff in the environment. And let's see. So this job happened to run at University of Colorado. So that's another quiz question I could ask. Look at your job log and figure out where you ran. So basically, yes, there's a bunch of different environment variables in here, right? Some of them you care about, some of them you don't. But for example, you can see here are these revision numbers I mentioned for the different CVMFS repositories. This happens to be Mu2 and Argonaut. Our startup scripts, when our pilot jobs run, they basically check for all Fairmont experiments, not just DUNE. Here's the DUNE osgstorage.org. We mentioned that's the stash cache. We mentioned a little bit about that yesterday, right? But yeah, so we kind of just go around and poke and go. Are we running in Singularity, which you can see from the process ID stuff in the other job log, which we don't need to check right now. But so this job completed, looks okay. Easy peasy. So who wants to be brave and tell me where their job ran? There will be an environment variable. You can either look, probably the best one to look at is this one, glide in DUNE site. So you can just grep for that or whatever. Let me put that in the chat. All right. Shall we go on? Before we do that, let me switch my sharing here because I think I broke something yesterday with the next part, and I want to make sure that I didn't do that. Okay, but you can see the web page still, right?
Yes, we can see the web page.
Okay, so while I double check this, so don't copy quite yet on this first batch step. I just want to make sure that this is okay. But while we're doing that, I can mention what we got there in the first part, right? Now in the last tutorial, I think we did the build a custom module before we did this part of the tutorial. But even if this is a little out of order, a lot of people will do this anyway. But the first thing to note about bringing in custom libraries, custom fickles, etc., in through tarballs, right? Because if it's not the stock release, then you have to get those files to the worker node somehow, right? We have mechanisms for that, as we'll show you. But the first thing to keep in mind is you may not need to do that, especially if, say, you want to not modify any code in the release, but you have some fickle file and you want to change a couple of lines. Now you could, yes, check out DUNE TPC or whatever package has that fickle in it. You could build the whole thing, set it up, make a tar file, change the fickle, schlep all that stuff to the job, set it up locally, and that'll work, yes. Or you could just add a couple lines in your script that copy the fickle in question to your Scratch working directory on the worker node, make the change there, and just run. In a second, I will show you how we do that in production, and that saves us a lot of hacking around with tarballs and that kind of thing, right? So,
and there are quite some interesting questions. If you can go on the tab with the great job submission Google, perhaps you can say a bit. I will point you to the question that would perhaps help people to follow. Scroll down, because Kirby handled a lot of it. Scroll down. So there is, the first question here, is there a place where you can see valid inputs for Append requirements? I can type if you want. And then the last question, can you go over submission test singularity.sh? I'm confused what the comments in this file do.
Okay, so we have a request to go over the script. Yes, I can. Let me, oh, that was, sorry. Let me just fix this other thing because I don't want you all to send a bunch of jobs that might fail, which would be bad. And wasting everyone's time. So let's, so the other question is, what are the valid things for target? There is a way to get that. It's slightly painful. So maybe I just say just a word about what is actually happening behind the scenes. So everywhere except for FermiGrid, we run within so-called glidins. Basically, these are pilot jobs. So this is very similar to CMS. Well, it's actually identical to CMS, as it turns out. So what happens is basically you submit a job like you do. And then the scheduler says, oh, okay, here's a job that needs whatever. Where can I run this job? I need to go request slots out at these other sites. So at other sites, what happens is you start this so-called pilot job, which is really just a job that blocks a certain number of cores and a certain amount of memory. And then inside of it, it starts a little Condor daemon that calls back to Fermilabs, the server you're submitting to, the job sub O whatever's, and says, hello, I am a slot. I have CVMFS. I have this much memory. I have this much cores. I will live for this amount of time. So give me some jobs. And then that pulls in your jobs and runs them. And this all happens without any user intervention at all, which is great. But when the glide-in starts, it runs a bunch of scripts that do all this checking. And that's what's setting all this target stuff. Typically, well, actually almost always, you only have to worry about a few things. The main ones, of course, are CVMFS. And just making sure you have singularity. So we were seeing somewhere the other day, especially for recent builds, that some jobs were failing because of an illegal instruction error. And the issue was that it was just a really old processor. So we at Fermilab basically, how would I put this, Mike? If a worker node is running well, we don't necessarily just retire them because it's old. So there are some 7, 8, maybe even 10-year-old worker nodes out there, which for 90-some% of things is perfectly fine. But depending on how you compile stuff, could be a bit of an issue. But there's a way to get around that. Sorry, this is a very long-winded answer to that question, but
basically the newer, right? I mean, Ken, what you're saying is the newer compilers and the newer CPUs and cores have instructions that are not available on older cores, right? We have new technology, and you want to make sure that you're not running compiled code that. Is that the question, or?
But that was kind of the statement I was making. Yeah, that there's a way you can do a target. I think it has AVX. Remind me to put that in the chat. You just add one of these requirements, and then if that is not available on that worker node, then your job won't start. If you have that in your requirements. So that's just same thing you're doing like with the has CVMFS and stuff, right? You're just protecting yourself from starting on a worker node where something's broken. But for example, if you're running a DUNE job and for some reason the May2021 repository is broken, but the DUNE one is working, maybe you don't care. That is pretty much never happens, by the way, that one is working and the others aren't. But anywho, right now, what was I gonna do? Right, I was going to show you. That script. Okay, so all right, so stop share. Share desktop. Okay, back here now.
Yeah.
Okay, so at the beginning, just saying, here's the date, here's where I'm running, here's the local user. We'll come to that later. Do not assume that you will be running under your Fermilab regular username. You almost certainly will not be. So there's a way to get around that too. We'll see that in the next script. So, okay, then basically you can ignore this part because this is just what experiment you're running on, and then it tries to figure out where the output directory should be. The DUNE's way down here somewhere. Yeah, PN. So if your experiment is DUNE, write the output prefix to be PNFS DUNE scratch users. Okay. So as you see, there's lots of experiments. Okay, and then, so this is just checking that all the appropriate certificates for authentication and things are present on the worker node, which again, if you're running now in Singularity, it should be. So this is a bit old. This should go away because we don't really want you to use global serial copy anymore either. But again, kind of not such a big deal now because if you're in Singularity, you have all this stuff anyway, because we put that in the image. Making sure I've got my proxy as it should be. Now, again, one thing I'll note here, I didn't write this down, but within a job, you should not have to worry about doing any authentication yourself, right? You shouldn't need to do KX509, bombs proxy init, et cetera, within your own script. That is all handled for you. The proxies are automatically renewed, so you should never have to touch that. Then I'm just seeing what release we're running in, and then ideally this will match my image. Should be an SL7, right? Even if the underlying worker node might be EL8 at this point. Just setting up doing the equivalent of setup DUNE, but for the common Fermilab repo. Setting up IFDHC, start to copy it back. Then if we're DUNE, I run setup DUNE sh also. And then I just basically print the group, and then here I run the environment command. Just dump the environment into this file. And this does a bunch of checking for paths and stuff for IFDHCP, which you don't care about. And then finally down here, I copy it back. Now, first thing I do is make sure that my output directory actually exists. Now, I was going to say this later, but I'll say it now since it's up here. Note the grid user environment variable. That is set automatically by JavaScript, and that is your Fermilab username. Okay. Like I said, if you ran who am I, we have no idea what that's going to be. But if you want to copy back to your directory, so to speak, point to it with the grid user environment variable, and then that would be K Herner for me, and whatever it is for you. And then if that exited with a non-zero exit code, I print a helpful message and says, I was not able to read this. There might be a problem. If it succeeded, then I actually do the copy back down here. I can pass extra IFDH options if I need to, which I don't in this case. So here's that file we made. Notice here how I'm using the cluster and the process environment variables, right? This is a very handy thing to do in all kinds of jobs. So cluster is, in your job ID, it's the number before the period. And as we said before, process is the number after the period. And then scratch dir was set up top in that big case statement, and then grid users. Then again, I check the exit code. If this did not exit 0, print a helpful message that said, hey, I didn't copy back. And then I exit with a non-zero code so that if I'm looking at my outputs later and say, hey, give me my jobs that exits with a non-zero code, it will show up. Any questions about that?
So far, so good.
Okay. Okie dokie.
I think it's just instructive to point out this use of cluster and process is how you make the individual jobs unique.
Right. Yes, thank you. Yeah, because remember, when you're copying to dcache, you can't overwrite an existing file, right? So if I just call this job output.log, and then I ran it, it'll work the first time. But if I run this a second time, I'm going to get an error on copyback, right, saying file exists. I think we saw that in the data management stuff yesterday. So as I think it was Robert, sounded like your voice, was just saying this is a good way of making sure that you have unique file names, and then you know exactly which file goes with which job. And yes, it is technically possible because the 3 job subservers have their own counter for the ID numbers. You could end up with the same cluster and process on different servers. The odds of that happening are very low, however. Okay. So maybe then we go back to the web page. Are you seeing the web page now?
Yep.
Yep, okay. All right, so what I suggest you do then is to just copy these files from my area, though if you have a custom directory you want to try yourself, you can. But if not, these are readable by everybody, so just copy those. Okay, then when you're done with that, let's have a look at the first one, the setup May21 tutorial grid. So we're going to run this in the run script. The script that actually runs on the worker node is going to source this script. Okay. So as you see here, we already mentioned about grid user. We're going to just set up the usual DUNE. Because we have this local products thing, we can run this setup grid step, and that will set up DUNE TPC for us. But imagine we were running something with just files straight from the release, and we weren't editing anything. We could then skip this part entirely. And then all we would need to do is set up DUNE TPC, whatever version. Then we could just go on. Okay. And you'd be surprised how often that would actually work probably better than moving the tarballs around. But okay. So what this does, right, this sources a script I made in here, which is setup-grid. Now I believe by default, when you do the new release and stuff, and I think this is all in the Larsoft custom module tutorial, you get a script called setup. So I made one called setup grid, and just so you can see what the differences are. So pretty much all we do is we switch from the hard-coded DUNE app users, whatever, wherever we made the area, and we switch to something based on environment variables, right? Remember, the DUNE app areas are not visible on any grid nodes. So if you try to read something from there, it's just not going to work. But what will happen through the magic of JobSub, when you make your tar file and submit it, it will put everything in this directory you can access with this input tar dir local environment variable. And then it'll just look like it does on the DUNE GPPM machine from that point down, okay? Okay, so once you have copied all that stuff, we should actually make a tar file. Now, you will notice here, I tried to be a little bit smart about what I copy rather than just tar up the entire directory. In particular, I want to draw your attention to the exclude option. So as it turns out, it depends on the package, but some packages, it turns out that most of their space they take up on disk is actually in the .git area because they've been written to so many times, blah, 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 blah. So who can tell me, if I bring in this tar file and I include all the .git stuff, what does my job, or what does Lars actually do with those files? Anybody want to hazard a guess? If I'm excluding them in the tar file, that's probably a pretty good indication, right? Everyone's so quiet. So anyways, point is, why haul around a bunch of files and ship them off to all these worker nodes? Well, I didn't see VMFS, but still. Why have that taking up space in my scratch area or wherever if I'm never going to even touch them? Right, the code will work perfectly fine without these .git files. So we're just going to leave them out. There are other directories you may want to do that with, especially if you have a work area where you've got, kind of testing root files, that kind of stuff. Basically anything that your code that you're running in the job isn't going to use, don't put it in the tar file. So once we have done that, we submit another job, which is this guy. So it looks pretty similar to what we had, right? But there are some new options here and a much longer requirements list. Well, it's not that much longer, it just looks longer because it's in this form. And then we're going to run a different script, right? All right, so to draw your attention to these new options, well, new relative to our previous example. So this -- tar file name, and this is the recommended way to do it now. So if you've got some input tar file, you can use this Dropbox : full path to file. Now it's okay to have this file on DUNE app or DUNE data or whatever, because it's only copied once at submit time. Okay, it's not copied for every time a job starts. It's not copied from this location. It's copied once at submit time from this location to the server and stage there. So it doesn't have to be in Dcache in this case. So what will happen then is the tarball will get untarred, or it will look like it's untarred anyway. As I said, this input tar dir local environment variable directory. That's the best way to access it. At the moment, you can only do one such tar file. If you need to copy in other files, which you may need to do, there is the -f option to JobSub submit. And what will happen there is any files copied in with -f, and you can use that as many times as you want, they will get copied to Condor Deer input. Now, this UCVMFS Dropbox, you don't actually need anymore because doing this is the default now. So basically what it is that this input target local will actually point to a location in one of these 4 CVMFS repositories here, 5 user 1 through 4, and it's random. So basically these things just rapidly publish, and then your job knows which one it went to, and the job won't start until your tar file shows up here. So then it untars it, and then it the contents appear in this input target local. Why do we go to all this much trouble? Why don't you just copy the file like before? Reason is, imagine you have multiple jobs that need this file starting on the same worker node. Imagine extreme case. Imagine you get 10 or 12 of these or something. In the old days, you would have to copy this tarball to the same worker node 10 times, and there would be 10 copies of it. This way, it just goes once, and it's there in CVMFS. The other jobs that come in later that use the same job go, oh, it's already in CVMFS, great. It's also good because CVMFS will handle deduplication quite well. So imagine you had multiple tar files that you're, like you run once a set of jobs, then you change something in the tar file and submit with a new one, but 99% of the tar file is the same. CVMFS can pack that all very efficiently. So this is the default way. It is possible to do things the other way, but I'm not going to show you how to do that because you probably don't need to. Now, there is a small chance, of course, that like any of the other CVMFS repositories, you might land on a worker node where one or more of these is broken. So we just extend our same Condor requirements thing. We just add additional requirements. We used to do all 4 because you don't know which one you're going to end up on, but they're identical. Okay. Last thing I want to mention on that, go ahead and submit this if you haven't already. In some cases, if you're used to copying in a tarball and then editing a file in it, you have to be a little careful because since this is now a symlink to CVMFS, that's all read-only, right? So the simple workaround is just make a copy of the file to some temp name in the Scratch directory in the job. Do whatever edit you're going to do, and then change the name to file you want to edit, and then it just will work like it normally does. So this gets kind of back to my point about if you need to make minor changes to a few files on the fly rather than copying stuff in all the time with tarballs. Okay, have most people been able to submit them?
Actually, can I suggest that as it's 9 a.m. right now, perhaps we take a small break, and then the people who are having difficulties, they can ask questions on the Google Docs, and then we can just have a moment to help people debug, because this is really not easy. So there is always this learning curve that people may need, and that also gives you a break for you, Ken. Which you may enjoy as well. And thank you for Heidi, Kirby, and others to help on the live doc to debug people's mistakes. This being said, we would really like to know among how many participants. We have 59 participants in here. Please send us feedbacks if you're stuck, if you have any issues and so, or if everything goes well. This will really help us to know how to best help you and make this interactive. Can Ken, you were mostly done the part before monitoring jobs, right?
Yes.
Okay.
That's a good place to stop.
That is, yeah, that is a good place to take a break. So this is a break. So for those who wants to really take a break. And during, I would say this 10 minutes, we can assist you. And this is important to send us feedbacks on where you are, what you do not understand, so that we makes it really tailored to you. And that helps you then be autonomous while submitting jobs. So we can resume at 10 past. And let me know, Ken, if this is okay to cover most of the rest in 15 minutes. And
for the monitoring and stuff?
Yeah, for the
monitoring. That's fast, yeah.
Okay, great. So just let's have a break right now. And please send us your issues on the Google Docs so that we can help you in the written form, and you can also talk if you want to talk. And happy breaks, okay? So let's reconvene at 10 past.
Oh, Steve had his hand up. I didn't see before.
Anything to say?
I was just trying to answer I was wondering what submission test singularity at SH, but I found it. I'm filling in that question on the 5.
Oh, yeah. It's just just I use for testing these sites. That's all.
Right.
Yeah. Oh, one thing I should have said. Are we recording still?
Yes, we're recording even.
We are still. Okay, yeah. So
yes, we are recording.
Okay. One thing I didn't mention before, where we have the example where we're doing the target has singularity bit, that is going to almost certainly get put into the default job sub requirements in the next few weeks. So eventually you won't have to do that. It'll basically be, that will be there automatically unless you specifically tell it you don't care, if that makes sense.
Okay, so then what we can do is that we can update the GitHub website when this is operational. And what I also suggest